All right, so by definition, some suggestions for solving related rate problems. First, sketch a figure if it's helpful. Next, we need to identify all relevant variables, including those whose rates are given and those whose rates are to be found, kind of like we did in the previous problem. We found out that we needed to determine what the dy dt was, how fast it was going down the wall. We knew dx dt, we knew the x, and we knew the y, and so that was all we needed to find. Then we need to express all given rates and rates to be found as derivatives. And then we need to find an equation connecting the variables identified in step 2. And then we implicitly differentiate the equation found in step 4 using the chain rule where appropriate and substitute in all given values. And then in 6, solve for the derivative that will give us the actual unknown value. Okay, so those are kind of the steps. Again, really the key one probably is solving for the picture and then going from there. All right, so this one we're supposed to repeat example 2 for the basically the end at 3 hours. So we're going to do this equation, except instead of changing after 2 hours, we're going to change that to 3 hours. So it says, suppose that two motorboats leave from the same point at the same time. One travels north at 15 miles per hour, the other travels east at 20 miles per hour. How fast will the distance between them be changing after 2 hours? All right, so let's draw a picture because that's kind of the first things we're supposed to do. And so if we do that, our picture is going to be, we're going to start here maybe, and one motorboat's going to go this direction, and the other one is going to go this direction. So the one going north is going at 15 miles per hour. The one going this direction is going 20 miles per hour. So let's call this X. Let's call this Y for no better reason. And we need to find basically how this one is changing. And again, it doesn't matter. Let's call that one C for no other reason. We could call it H, we could call it Z, we could call it whatever we wanted to, but we just have to figure out what it is. Okay. All right. So then what do we have? Well, we have again the Pythagorean theorem. We can say x squared plus y squared equals what? C squared. Okay. And what we're wanting to find is we want to find how this one is changing. So we want to find dc dt at what we want to at t equals 3 hours. Okay. So what do we know? Well, if after 3 hours, what do we know about x? Well, x in 3 hours. So x at 3 hours is equal to what? Well, 3 times 15 is they've gone apparently 45 miles. Y at 3 hours, on the other hand, well, if they're going 20 miles an hour, that's going to go 60 miles. Okay. So then we know that when this is 45, this one's 60, what is C? Oh, that's going to be then 45 squared plus 60 squared equals C squared. And if we solve that for C, what we're going to get is we're going to get 75 miles. So now we know X, Y, C. We know the change in X, we know the change in Y, and now really all we have to do is find that change in C. So again, we're going to do the same thing as we did before. We're going to take the derivative of this equation. So we'll have x squared plus y squared equals c squared. And we're going to do implicit differentiation. And so that's going to give us what? Well, that's going to give us 2x dx dt plus 2y dy dt equals, now this one is a variable at this point in time, so it's going to be 2c dc dt. And a key here is dc dt is what we're looking for, so we really have to have that as a variable, not as a number. Now, we know all these things because we said that dx dt is equal to what? Well, that one's 15 miles per hour. dy dt is equal to what? Well, that one's going to be the 20 miles per hour. So we know dx dt, dy dt. We know x, y, and c. So we know x, y, and c. And all that's left is the dc dt. And so we can solve for that. So plugging everything in, we have 2 times 45 times 15 plus 2 times what? 60 times that changes 20. And then that's equal to what? 2 times 75, and then dc dt. So if we divide this whole thing by what, 150, and divide this whole thing by 150, that gives us dc dt equals, and if we plug all that into our calculator, we get 2 plus it looks like 25. So 25, and the change is miles per hour. Okay. And so that is how C is changing when this one's going up 15 miles an hour, this one's going to the right by 20 miles per hour, this one's changing by 25 miles per hour. Okay, so that's how we solve this problem. Again, the key was first setting up a picture, drawing what we knew, coming up with an equation, and simplifying for all the actual items we do know, the x, y, and c. And then we also knew the dx, dt, dy, dt, and then we just simplify by first implicit differentiation, plugging everything in and solving for what we don't know. All right, so let's stop there and we'll come back for more.